You probably drive over it every single day, right? But the most complex piece of chemical engineering on your entire property isn't your HVAC system. It's not your smart fridge either.
No, definitely not.
It's actually the flat gray slab you park your car on. We tend to think of a driveway as just this, utilitarian, static place to leave a vehicle.
Right, just a spot for the car.
Yeah, exactly.
Yeah.
But the reality is that surface is taking an absolute beating. I mean, it is the single hardest working structural element of a home.
Oh, without a doubt. It carries thousands of pounds of crushing weight day in and day out while being constantly exposed to, well, every extreme element the environment can throw at it.
It's wild to think about.
It really is. And to survive all that, a driveway can't just be poured like pancake batter. It has to be highly engineered from the dirt up.
Which brings us to today's topic. We are pulling from a really fascinating document for this deep dive. It's called The Definitive Guide to a Durable Cement Driveway in Fort Smith, put together by the team at 479 Concrete Fort Smith.
It's a great resource, really eye-opening stuff.
Yeah, it really is. And our mission today is to uncover the surprising science, the precise engineering, and the long-term economics hidden right beneath our tires. So, okay, let's unpack this, because to actually understand a driveway, we have to ignore the concrete entirely for a minute. We have to look at the dirt.
Yeah, that's where everybody gets it wrong. We assume the visibly flat, clean surface we drive on is the whole job.
Right, because that's all we see.
Exactly. In truth, that top layer is just the final fraction of a massive construction process. The hidden foundation entirely dictates whether that driveway lasts 5 years or 50.
50 years is a long time for a slab of rock outside.
It is. And before a single drop of concrete even arrives, contractors are out there executing heavy excavation. They have to strip away the unpredictable topsoil to get down to a stable subgrade, and then they aggressively compact that earth.
Right, and the guide mentions that if they skip that compaction or, just do a bad job of it, the soil eventually settles unevenly.
Oh, it's a disaster when that happens.
I can imagine. Because suddenly, the rigid concrete sitting above it is essentially hovering in midair with zero support underneath.
Yep, creating massive hollow voids.
And that's when you get structural cracks, surface scaling, and those weird uneven dips that turn into massive puddles every time it rains.
Yeah.
Think of it like the foundation of a house. You can't build a heavy, lasting structure on top of soft, shifting mud.
No, you definitely can't. And to prevent that water pooling, the next critical step is bringing in a thick base layer of crushed stone or gravel.
Just regular gravel.
Well, specific crushed stone, yeah. Because this isn't just about giving the concrete something hard to sit on. It is a highly functional drainage system.
Oh, I see.
Think about it. When water seeps down through the ground, the gravel gives it the physical space to drain away from the bottom of the concrete slab.
So it keeps the moisture from just sitting there and eroding the bottom of the foundation.
Exactly. Establishing that drainage and compaction requires a serious logistical dance, too. We were talking about professional contractors bringing in heavy machinery like skid steers and plate compactors.
Like navigating tight residential streets.
Navigating the streets, prepping the site, all while simultaneously trying to time the arrival of the delivery trucks.
Because the timing is brutal, right? It's like a high-stakes race against the clock.
It is entirely a race against time. Once that wet mixture is loaded into the drum of the mixing truck, a chemical countdown literally starts.
Wow.
If a truck gets stuck in traffic, or maybe the site prep just runs late, the mixture actually starts heating up and setting prematurely right there inside the spinning drum.
So they basically ruin the whole batch.
Pretty much. By the time it hits the ground, it has to be poured seamlessly, because what comes out of the chute isn't just heavy mud. It is a volatile, highly precise chemical equation.
The science happening inside that wet mix is wild to me. The guide highlights the water-to-cement ratio as this incredibly delicate make-or-break balance.
It is the most critical part of the pour.
Right. So if a contractor gets lazy and adds, say, too much water to make the heavy sludge flow easier out of the truck,
Which happens more often than you'd think.
I bet. But if they do that, the extra water molecules physically push the cement particles further apart, and that permanently weakens the final product.
Exactly. But on the flip side, if they use too little water, the mix becomes an absolute nightmare to work with. It traps internal air pockets that compromise the whole structural integrity.
It sounds like a total headache.
Yeah.
But even when that chemical ratio is flawless, concrete inherently has a fatal flaw, doesn't it?
It does. It is phenomenally strong under compression, meaning it can hold up a heavy truck pushing straight down.
Right.
But it is remarkably weak when it comes to tension, which is pulling and bending forces.
Because the ground moves?
Well, even just driving on it. When a vehicle drives over a slab, the concrete flexes ever so slightly, creating tension. Without help, it would just snap.
And that is why they put those heavy-duty wire mesh or steel rebar grids inside the wet pour.
Exactly. The steel acts like a skeleton.
I love that visual. So it provides the tensile strength the concrete lacks, holding the entire slab together from the inside out.
Yeah.
So you don't get those wide, gaping structural cracks when heavy loads flex the surface.
You've got it.
Mhm.
But getting the pour flat and the steel set is only half the battle. The true durability of the surface is decided over the next several days through the curing process.
The curing process.
Right. And the primary goal of curing is to ensure that moisture is retained tightly inside the newly poured material for as long as possible.
Wait, if you want something to dry and get hard, why would you actively trap the moisture inside of it?
What's fascinating here is that concrete doesn't actually dry out in the traditional sense.
It doesn't.
No, it's not like a wet towel sitting in the sun where the water simply evaporates. The hardening process is a continuous heat-generating chemical reaction called hydration.
Oh, wow.
Yeah, the cement compounds literally react with the water molecules to grow microscopic interlocking crystals.
That sounds like something out of a sci-fi movie.
Right. And these crystals bridge the gaps between the sand and gravel, locking everything into a solid mass.
Ah, okay, so it needs the water to physically build its own internal structure.
Exactly. If the sun bakes the water out of the concrete too fast, the crystallization just stops in its tracks. The driveway never reaches its potential strength.
So how do they stop the sun from ruining it?
Contractors spray specialized liquid curing compounds over the finished surface.
Okay.
These compounds form a temporary membrane that seals the moisture inside. This ensures the top layer, which is baking in the hot sun, continues to hydrate at the exact same rate as the bottom layer, which is buried against the cool gravel.
Because without that seal, the top layer shrinks and cracks while the bottom is still expanding, I assume.
Exactly. It would tear itself apart.
You know, knowing the immense amount of chemistry, heavy machinery, and steel required just to put a slab in the ground,
Yeah.
it completely shifts how you view the price tag.
It really recontextualizes the cost.
It does. But let's say a contractor hands me two quotes. One is for concrete, and the other is for asphalt. And the asphalt comes in significantly cheaper for day one. When you are staring at a massive home improvement bill, I mean, I'm taking the cheaper option. Why would anyone pay the premium for concrete when asphalt is right there?
If we connect this to the bigger picture, it comes down to understanding the total cost of ownership over a 30-year timeline, rather than just the initial sticker shock.
Okay, so looking at the long game.
Right. With asphalt, you aren't just buying a driveway. You are essentially committing to a decades-long part-time job.
How so?
Asphalt is a petroleum-based product, so under intense summer heat, it softens. Heavy tires will leave permanent ruts.
Oh, right, I've seen that on roads.
Yeah, and UV rays break down its binders, meaning you are trapped in a cycle of paying for professional seal coating every few years just to keep it from crumbling. Over 30 years, the upfront savings of asphalt are completely devoured by those endless maintenance costs.
That makes a lot of sense. And not to mention the alternatives like loose gravel.
Right, gravel is another one.
Sure, gravel is incredibly cheap up front, and it gives a really nice rustic look. But the expected lifespan is, what, maybe 1 to 5 years
Right.
before it's completely rutted out.
If you're lucky, yeah.
You are constantly buying new truckloads to replace what washes away in the rain. You're out there raking it, endlessly pulling weeds. It sounds awful.
It is a lot of work. And then there are interlocking pavers, which are another popular option.
Yeah, people love the look of pavers.
They do. They offer a premium, varied look, and they can actually last 25 to 50 years, much like concrete.
Oh, that's pretty good.
It is, but they also require moderate maintenance. Weeds grow between the joints, and individual stones can settle unevenly over time as the ground shifts.
So if we look at the data, poured concrete, which lasts 30 to 50 years, essentially eliminates that cycle of chaos.
Exactly. You pay a higher premium up front for the rigorous excavation, the steel reinforcement, and the precise chemistry, but once it's cured, it fundamentally takes care of itself.
No rutting in the heat.
No.
No weekly weed pulling. No biannual sealing schedule just to keep it intact. You are basically paying for the peace of mind that your driveway isn't a degrading asset you have to constantly manage.
That's the perfect way to phrase it. And if you are going to invest in a structure engineered to last half a century, it shouldn't just be functional, it should elevate the aesthetic value of the entire property.
Which is huge for home value.
Absolutely. The era of concrete being nothing but a flat, boring, gray runway is completely over.
Well, here's where it gets really interesting. The guide breaks down modern aesthetic upgrades, specifically something called integral coloring.
I love integral coloring.
It's amazing. I always assumed if you wanted a brown or terracotta driveway, they just painted or stained the top layer after it dried. But to make it last decades, they actually add the color pigment directly into the mixing truck.
Before they even pour it.
Right. I like to picture it like the difference between a painted apple and a carrot.
That's a good analogy.
Right. Like if you scratch an apple, you see the white underneath. The color's only on the skin. But you scratch a carrot, it's orange all the way through.
Yep.
With integral coloring, the concrete itself is the color. Even if the surface wears down over 20 years of driving, the shade remains completely uniform.
And they frequently pair that integral coloring with stamped patterns, which takes it to a whole new level.
How does that work?
While the concrete is still in its wet plastic state, contractors press heavy, specialized polyurethane mats directly into the surface.
Oh, so they are physically stamping it. It creates physical, three-dimensional textures.
Exactly. It isn't a flat visual print. You can actually feel the grooves. It physically mimics the appearance of natural slate, cobblestone, traditional brick, or even wood planks.
That's incredible. So you get the high-end, luxury look of custom masonry, but you keep the legendary unified strength of a solid steel-reinforced slab.
You do. And homeowners quickly realize the value of this aesthetic flexibility. Upgrading the main vehicle entrance often inspires a cohesive design language across the whole property.
Yeah, because you can have the same concrete contractor extend that exact design into the backyard.
Right.
Like pouring patio slabs for outdoor kitchens, custom fire pits, or heavy seating areas. By using one unified team, you guarantee the surface textures match, the custom color palettes are consistent, and the rigorous structural engineering standards are applied everywhere.
It turns a basic yard into a premium outdoor living environment.
But, and this is the big but, all of this premium design, the expensive color pigments, the heavy-duty steel, it means absolutely nothing if the local environment tears the slab apart.
That is the harsh reality. The structure has to be engineered to survive the real world.
And according to the team at 479 Concrete, the real world of Fort Smith, Arkansas is incredibly volatile.
It really is. Arkansas weather introduces highly specific, aggressive challenges for exterior construction.
What makes it so tough?
Well, you have intensely hot, humid summers, followed by unpredictable winter nights that rapidly drop below freezing. That extreme, rapid temperature swing causes the earth and the concrete itself to expand and contract repeatedly.
That sounds like a recipe for disaster. And to make matters much worse, the local soil in that region is incredibly clay-heavy.
Yes. Clay is a nightmare for foundations.
Because clay isn't just regular dirt that gets muddy, right?
No, not at all.
On a microscopic level, clay is made of tiny, plate-like structures. When it rains, those plates trap water molecules between them and aggressively swell. They push upward against the driveway with thousands of pounds of hydraulic pressure.
It's immense force.
And then, during a dry summer heat wave, those plates lose their water and violently shrink, leaving the driveway basically suspended over empty voids again.
Exactly. That violent ground movement requires highly adjusted subgrade preparation just to keep the slab from snapping in half.
But even with perfect subgrade prep, the concrete itself is still going to undergo thermal expansion and contraction, right?
It is unavoidable.
Because it is rigid material, which means as it shrinks and swells with the seasons, it inherently wants to crack.
It absolutely wants to crack. And to manage this, engineers rely on control joints.
So what does this all mean? Like, how do control joints stop the cracking? I guess think about control joints like the perforations on a notepad or a sheet of postage stamps.
That's a great way to visualize it.
Because you know the concrete is going to build up stress and eventually crack no matter what. You take a saw or a grooving tool and make deep, strategic cuts at specific intervals.
Right.
You are intentionally telling the concrete exactly where it is allowed to break. So the stress fractures happen down inside those hidden joints, so the surface doesn't tear itself apart with ugly, random spiderweb cracks right across the middle of your beautiful stamped cobblestone pattern.
Exactly. It is the engineering of controlled failure.
Controlled failure. I like that.
But even with control joints hiding the stress fractures, if you park a massive RV on a standard residential driveway, it's going to crush it anyway.
Really? just from the weight.
Oh, yeah. That's where the physical thickness of the slab comes into play. 4 inches is the strict industry standard for everyday passenger
Okay,
vehicles.
so 4 inches for a regular car.
Right. But if a property owner frequently parks heavy pickup trucks, large recreational vehicles, or heavy landscaping equipment, a 4-inch slab will absolutely suffer structural failure over time.
So they need to upgrade to a 5 or 6 inch thickness,
Yeah.
which provides the sheer mass needed to bear those extreme loads.
Exactly. But you have to keep in mind that extra thickness also impacts the timeline.
Oh, the waiting game. We've talked about all this complex chemistry and hydration, but how long does it actually take before you can use the driveway?
The guide outlines a really strict waiting game. You can typically walk on a newly poured surface within 24 hours.
Okay, so foot traffic is fine pretty quickly.
Yes. However, you must wait at least 7 full days before putting a vehicle on it.
7 days.
Yeah,
Wow.
it's crucial. And the chemical hydration process we discussed earlier, the crystal growth locking the structure together, doesn't reach its maximum structural strength until 28 days have passed.
28 days. That demands a lot of patience from the homeowner.
It really does. And once it's cured, it does require a minimal amount of ongoing care.
Maintenance.
Right, because concrete is a naturally porous material. On a microscopic level, it's full of tiny holes.
So you have to seal those holes. Applying a high-quality topical concrete sealer every 2 to 3 years is the main defense against those pores.
Yes, the sealer acts as an invisible shield.
It stops deep moisture from penetrating the slab, which is critical. Because if water gets inside those pores and freezes during an Arkansas winter, it expands and literally shatters the concrete from the inside out.
It's called spalling, and it ruins the surface.
And the sealer also repels chemical spills, automotive oil leaks, and UV damage, giving the color bright and vastly extending the functional lifespan.
Which is why this deep regional knowledge understanding the local weather is why choosing the right local partner is vital.
Right.
The volatile freeze-thaw cycles and the hydraulic pressure of clay-heavy soils aren't generic problems. They are highly specific environmental threats.
Yeah, you can't just hire someone who doesn't know the local dirt.
Exactly. Understanding those local nuances is the fundamental difference between a driveway that fails and cracks in 5 years and one that flawlessly endures for 50.
It really brings everything full circle. We started by saying a driveway is just a flat place to park, but hopefully you, the listener, can now see it for what it truly is.
It is so much more than a slab.
It is a deeply engineered, chemically complex structure. I mean, from the heavy excavation and crushed gravel drainage up through the steel-reinforced tensile strength and the heat-generating chemical hydration.
All the way to the 3D stamped aesthetics and carefully mapped control joints.
Exactly. It is the literal physical foundation for a home's curb appeal and outdoor living space designed to perform under immense pressure for decades.
It really is a marvel of everyday hidden engineering. And as we wrap up, this raises an important question based on what we've unpacked today.
Oh, what's that?
Well, we saw earlier that interlocking pavers can last just as long as concrete, offering a premium look.
Right, 25 to 50 years.
But considering the heavy emphasis on Fort Smith's aggressive freeze-thaw cycles and those expanding hydraulic clay soils we just explored, what happens to hundreds of individual segmented pavers when the ground violently heaves and moves beneath them?
Oh, right. Compared to a unified steel-reinforced slab that is anchored together and moves as one solid, massive piece.
Exactly. Does the inherent flexibility of individual pavers become a distinct liability in volatile clay soil? Does it eventually lead to a wavy, uneven driveway full of tripping hazards?
That is a really great point. It is definitely something for you to mull over as you consider whether a unified slab or individual stones are better equipped to survive a deeply unpredictable climate.
Lots to think about.
Absolutely. So next time you pull in, put the car in park and step out, just take a second to think about all the intense science and hard work happening right beneath your tires.